let us discuss some previous IIT JEE problems on the chapter binomial theorem. Question number 1. If the sum of the binomial coefficients in the expansion of a plus b power n is 4096, then the greatest coefficient in the expansion is first option 1594, second option 792, third option 924, fourth option 2924. Okay. Now let us look at, we are given that the sum of the binomial coefficients is equal to 4096. Okay, so what is sum of the binomial coefficients? NC0 plus NC1 plus so on NCn. We know it's equal to 2 power n, and that is given to be 4096. This is given. Okay, so what should be n? What power of 2 is going to give us 4096? 2 power 12 we know is 4096. Therefore, n has to be 12. So there are, n is 12, obviously there will be 13 terms, because in the expansion of a plus b power n, when n is 12, we will have 12 plus 1 term, that is 13 terms. Therefore, we have, and what will be the greatest binomial coefficient? You know that the binomial coefficients keep increasing like this, and 12C6 will be the largest one, and that will be largest. 12C7, this is the largest binomial coefficient. 12C6 is the largest, and 12C6 we know is 12 factorial by 6 factorial into 6 factorial. That turns out to be, with a simple calculation we can see that it is 924, and clearly the option is 3. Answer is 3 there. Okay, let's move on to the next question. The positive integer just greater than 1 plus 0.0001 raised to the power 10,000 is, options are 1, 4, second option 5, third option 2, fourth option 3. Okay. Now 1 plus 0.3 zeros followed by 1 raised to the power 10,000. Observe that this is the form 1 plus 1 by 10 power 4 raised to the power 10 power 4. Now consider the expansion 1 plus 1 by n whole power n. This can be written in the form 1 plus n into 1 by n plus nc1, I am writing it as n, nc2 will write it as n into n minus 1 by 2 factorial into 1 by n square. Now so on and so forth. nc3 will write it as n into n minus 1 into n minus 2 by 3 factorial into 1 by n cube plus so on. The last term will write it as ncn, will write it in the form of n into n minus 1, so on and so forth, up to n minus of n minus 1, that is 1 by n factorial. This is simply n factorial by n factorial, that into 1 by n power n. Let's write it like this. Okay. Now what is that? 1 plus, after simplification, n into 1 by n will make it 1. Next, what we'll do is, there are two factors of n here, 1 by n square. We will take one n factor to this, and one n factor will divide it with n minus 1. Okay, right? So we will split this 1 by n square into the two factors and write it as n by n and n minus 1 by n into 1 by 2 factorial. The next term we'll write it in the form of, again there are three factors and three factors of n. There are three factors involving n here, n into n minus 1 into n minus 2 we will take each factor of n underneath these factors of n. So we'll get n by n into n minus 1 by n into n minus 2 by n into, of course, with that 1 by 3 factorial, we'll write it here. So on and so forth. What is the last term that we have here? Again 1 by n factorial, and there are n factors of n which are getting divided here, and what we'll do is we'll split that n factors into each of these n factors here. So again I'll get n by n, n minus 1 by n, so on and so forth. How many brackets like this? There will be n brackets, n minus of n minus 1 by n. It is getting split into n brackets there, into 1 by n factorial. Now observe that this can be rewritten in the form of 1 plus 1 plus 1 by 2 factorial into 1 into 1 minus 1 by n plus 1 by 3 factorial into 1 minus 1 by n into 1 minus 2 by n, so on and so forth. The last being 1 by n factorial into 1 minus 1 by n, 1 minus 2 by n, so on, dot dot 1 minus n minus 1 by n. Okay, we can write this. Now observe that this 1 minus 1 by n is definitely less than 1. This part is less than, is a product of two numbers which are both less than 1. This, so here there are, it's a product of n numbers which are less than 1. So what do you get? Each of these parts will, each of the parts in the bracket are less than 1, and the product of two numbers which are less than 1 is also less than 1 there. Therefore what do you have? 1 plus 1. I am just carrying this one here, and I am going to write less here symbol, because these factors are, these terms are less than 1. So 1 by 2 factorial, and this part is less than 1. So I am just going to write 1 by 2 factorial plus next 1 by 3 factorial into, this entire thing is less than 1. So into, this will be less than 1 by 3 factorial, so on and so forth. Each of these terms, this will be less than 1 by n factorial. Last term will be less than 1 by n factorial. So we have a summation like this. This 1 plus 1 by n whole power n is less than all this. Now there is one more thing that we should know here. 1 by 2 factorial is, I can say, less than or equal to 1 by 2. It's equal in fact. So we'll just say 1 by 2 factorial less than or equal to 1 by 2. What about 1 by 3 factorial? Can I say it is less than or equal to 1 by 2 into 1 by 3? This is 1 by 2 into 1 by 3. So we'll write this to be less than 1 by 2 square. That is, I am comparing this series, this factorial series, with a geometric series. Why am I doing that? Because we know the sum up to n terms of a geometric progression. So 1 by 4 factorial, we are going to write this 1 by 4 factorial to be less than or equal to 1 by 2 into 1 by 2 into 1 by 2. Because that 1 by 4 is less than 1 by 2, 1 by 3 is less than 1 by 2, and we have this. In fact, strict inequality holds good, so we can write like that. So what is that? 1 by n factorial is less than, in fact, less than 1 by 2 power of n minus 1. And we'll write 1 less than or equal to 1. This 1 less than or equal to 1. Now let us add up. I'm separating this 1 out, and we have this n terms here. 1 by 1 factorial, 1 by 2 factorial, 1 by n factorial. So these n terms here are being compared with n terms of a GP, which is the common ratio half there. So what is that going to be? The summation will be the sum. The sum will, let me call it as S here. That sum will be less than or equal to 1 plus 1 by 2 plus so on 1 by 2 power n minus 1. And you know that this is only sum up to n terms of the GP. This has to be definitely less than 1 plus 1 by 2 plus 1 by 2 square, so on up to infinitely many terms of the GP, up to infinity. But what is the sum equal to? The sum up to infinitely many terms of the GP is a by 1 minus r whenever mod r is less than 1. So what do we have? 1 by 1 minus half. So what is that equal to 2? So this part of the sum is less than 2.
Therefore, the entire, and you are adding a 1 here. So what does it mean? This 1 plus 1 by n whole power n will have to be strictly less than, this is 1, okay, this is less than 1 plus, you have just now seen that this is less than 2. So this is less than 1 plus 2. Therefore, this expression has to be always less than 3. So 1, now don't you see it is in the form of 1 plus 1 by 10 power 4 raised to the power 10 power 4. So that is less than 3. Okay, so the greatest, the positive integer just greater than this number will be 3 there. Okay, so we have this to be less than 3. Well, let's move on to the next question here. The number of integral terms in the expansion of square root of 3 plus 8th root of 5 raised to the power 256 is, first option 32, second option 33, third option 34, and fourth option is 35. Let's have a look at this. Root 3 plus 8th root of 5. This root 3 will also write this in the form of 3 power half, 8th root of 5 whole raised to the power 256. Now what is the general term in this expansion? The general term in the expansion is 256 CR into 3 power half raised to the power 256 minus R into 5 power R by 8. This is the general term. R can be ranging from what to what? 0 to 256. This is the general term, and R can be ranging from 0 to 256 there. Now we want this, we want to know for how many values of R this is going to be an integer. Now clearly this part is an integer, this is an integer, because what is this? NCR form. We are choosing R things out of n things, it's always an integer. So integer here. Now we want 256 minus R to be divisible by 2. So because this has to be an integer, right? So 256 minus R must be a multiple of 2. M of 2 means multiple of 2. Of 2. Okay, so now since 256 is already a multiple of 2, R should also be a multiple of 2. Because when can the difference of two numbers be multiple of 2? Okay, either both are even or both are odd. Right, so this being even, this R must also be even. So R is a multiple of 2. R must be definitely a multiple of 2. Okay, now, so what are all the multiples of 2? So we have to rule out these numbers, odd numbers. So that discounts all the odd numbers there. Okay, now what else we want? R should be a multiple of 8, because 5 power R by 8 we are talking about. When can that 5 power R by 8 be an integer? Only when R is a multiple of 8. Since 5 power R by 8 has to be an integer, we want R by 8 to also be integer. So R must be a multiple of 8. Now you are saying here R is a multiple of 2 and R is a multiple of 8. If R is a multiple of 8, it implies that R is a multiple of 2 as well. So what we want is R is multiple of 8. From these two we can conclude that we want R to be a multiple of 8. So now we have to look for multiples of 8. How many multiples of 8 are there here? We'll divide by 256 by 8. Okay. So what is that? We have how many multiples of 8 are there which are less than 256? 3 8 is 24. And then we have, okay, we have, and then 1 6, so 32 there. So 32 multiples of 8 are there. But then 32 plus 1. Why? 32 into 8, 0 is also to be taken now. So what is it? So 0 into 8, 1 into 8, so on, 32 into 8. So we are counting from 0 to 32. So totally how many numbers are there? 33 numbers are there. So therefore, the number of integral terms is as good as counting the number of values of r for which this portion will be an integer as well as this portion will be an integer. That means r by 8 must be an integer. Therefore, r must be a multiple of 8. R by 2 must be a multiple of 2. From these two we can conclude that r has to be a multiple of 8. So now how many multiples of 8 are there in the list of 0 to 256? So those many integral terms will be there. So how many are there? It is 33 there. Okay. So we have counted here, there are 33 numbers. So therefore the answer is 2. Now let's move to the next question. If x is positive, the first negative term in the expansion of 1 plus x raised to the power 27 by 5 is, first option 7th term, second option 5th term, and third option 8th term, fourth option 6th term. Now first of all, let us look at 1 plus x to the power p by q expansion. Now what is the general term in this? We know that whenever we have a binomial raised to a rational index, the r plus 1th term, tr plus 1, will be p by q into p by q minus 1, p by q minus 2, so on, p by q minus r minus 1 by r factorial. So this is replacing NCR part when n is a natural number. So n into n minus 1 into n minus 2, so on, n minus of r minus 1 divided by r factorial into x raised to the power n. Instead of n we have p by q. Okay, right. So can we rewrite this in the form of p? I will take out a q as many x, sorry, this is x raised to the power r here. Okay, so we have here p into p minus q, p minus 2q, p minus 3q, so on, p minus r minus 1 into q, divided by r factorial. Now in each, how many factors are there in this? There are r factors in this, in the numerator, and each factor is carrying out a q. All that q factors, I mean all the factors of q, r factors of q, I am going to club here. So I will have 1 by q into x whole thing raised to the power r. So we can rewrite the general term in the expansion of 1 plus x power p by q, whenever p by q is a rational number, is in the form of p into p minus q into p minus 2q, so on, p minus 3q, so on up to p minus of r minus 1 into q by r factorial into x by q raised to the power r there. Now we are interested in the first negative term. So what should be the value of r so that, okay, what should be the value of r so that one of the least value of r for which this expression is going to be negative here. Okay, so here 1 plus x raised to the power 27 by 5. Let's come to that. Your p is equal to 27 and q is equal to 5 there. So we have here, so 27 into 27 minus 5, 27 minus 10, 2 into 5, 27 minus 3 into 5, 15. So 27 minus 6 into 5. If you write up to 6 into 5, now what is 27 minus 5 into 5? That's going to be positive. So when I introduce r to be r minus 1, if it is becoming 6 there, then that is going to be the negative thing. So I observe, what we observe here is what is the least value of r for which I am going to get a negative factor out here in the numerator, r factorial. Okay, observe that it is happening for r is equal to 7 there, because r minus 1 is 6 there. So it is happening when 27 minus 6 into 5, that is the least, that is the first negative factor that you come across in this product in the numerator. What would be the term previous to it? 27 minus 5 into 5, that's a positive quantity. So next 27 minus 6 into 5, that is the first negative quantity. From there on I will be getting the negative quantities there, and you know that this x is a positive quantity that's already given, and q is 5 there, x by q power r, this is anyway positive. So the term will be dependent on, okay, the positive or negative part will be dependent on only this part, the numerator here, and the numerator is negative when for r is equal to 7 there. The first term when the numerator becomes negative is r value is equal to 7. So therefore r must be equal to 7. Okay, so which means that it is, if r is 7, which is the term? What is the term position? If r is 7, the term position is 8. So the answer is T7 plus 1 is the first term which becomes negative. Okay, so the answer is T8. That comes in the option 3 there, answer 3. Let's move to the next question. The coefficient of the middle term in the binomial expansions in powers of x of 1 plus alpha x raised to the power 4 and of 1 minus alpha x raised to the power 6 is same if alpha equals to, first option minus 5 by 3, second option 3 by 5, third option minus 3 by 10, fourth option 10 by 3. Now 1 plus alpha x raised to the power 4, it has 5 terms, and clearly the third term is the middle term, and T2 plus 1, that's the middle term. What is the middle term? Is third term, because this has 5 terms, T1, T2, T3, T4, T5. Clearly it has 5 terms, and obviously the third term is the middle term, so T2 plus 1. So what is that? 4C2 into alpha x raised to the power 2 there. So what is the coefficient here? The coefficient is 4C2, is not asking only for the binomial coefficient, is asking for the coefficient of the powers of x. So it is 4C2 into alpha square. That's a coefficient. Coefficient is 4C2 into alpha square. Now in the expansion 1 minus alpha x power 4, 6, the next expansion, we have 7 terms. This has 7 terms. T1, T2, T3, T4, T5, T6 and T7. So there are 7 terms. Clearly T4 is the middle term. So that's the middle term. This is T4, which is the middle term. Okay, now what is the T4 here? That is T3 plus 1. That's going to be 6C3 into minus alpha x raised to the power 3. So that makes it minus 6C3, because alpha into alpha cube is the coefficient. This implies the coefficient is equal to this, minus 6C3 into alpha cube. He says these two are equal. So 4C2 into alpha square is equal to minus 6C3 into alpha cube. Okay, so we'll just cancel out this alpha square. Here we have alpha. So what is alpha now? Alpha has to be minus 4C2 divided by 6C3. And what is 4C2? That is 6. And 6C3, how do you calculate 6C3? 6 into 5 into 4 by 3 factorial. That makes it 20. 6 by 20. With a minus sign, what is that? It's clearly minus 3 by 10. So that's minus 3 by 10. 4C2 is 6 and 6C3 is 20. So therefore the value is 6 by 20, but we have a minus sign there, therefore it's minus 3 by 10, and clearly the option is 3. Let's move to the next question. If the coefficients of r term, r plus 1 term and r plus 2 term in the binomial expansion of 1 plus y raised to the power m are in arithmetic progression, then m and r satisfy the equation m square minus m into 4r minus 1 plus 4r square minus 2 is equal to 0. Second option, m square minus m into 4r plus 1 plus 4r square plus 2 equal to 0. Third option, m square minus m into 4r plus 1 plus 4r square minus 2 is equal to 0. Fourth option, m square minus m into 4r minus 1 plus 4r square plus 2 is equal to 0. Now, in the expansion 1 plus y power m, the coefficient of rth term, rth coefficient will be mcr minus 1. R plus 1 the coefficient is mcr, and r plus 2 the coefficient is mcr plus 1. These are clearly in AP given. This is given. So what does that mean? 2 into mcr, 2 times the middle term has to be equal to sum of the extremes, mcr minus 1 divided by mcr plus 1. Okay. Now can we write this way? 2 is equal to, I divide by mcr. What do I get? mcr minus 1 by mcr plus mcr plus 1 by mcr. Okay. We have a result here at the key point here. Let's make a note of this. Note here, ncr by ncr minus 1 is equal to n minus r plus 1 by r. Okay. So if you had ncr plus 1 by ncr, what would it be that? In place of r, I'll have to write r plus 1. So n minus of r plus 1 by r. What does that make it? N minus r by r. In place of r, I have r plus 1. Sorry. So n minus r by r plus 1. So instead of n, we have m here, and in this we have the reverse. It is mcr minus 1 by mcr. So what should it be? The reciprocal of this. So r by n minus r plus 1. Instead of n, we have m here. So r by m minus r plus 1. And what about here? It is in the order ncr plus 1 by ncr type. So this should be, instead of n, we have m. So m minus r divided by r plus 1. That is equal to 2. Now just take the LCM and then cross multiply and make the manipulation. It's clearly a quadratic equation that you come across, and that will be the answer 3 there. So it's a simple calculation that we just require to do here, and the answer is 3. Option is 3. So the key point that we have used was ncr by ncr minus 1 is equal to n minus r plus 1 by r, and therefore if I make a shift of r to r plus 1, ncr plus 1 by ncr would have been replace r by r plus 1. So it minus n minus r by r plus 1 is what you have there. I have used it, and it's a simple calculation and that you need to do here to make it appear as the option 3 there. So answer is 3. Let's move to the next question. Question number 7. If x is so small that x cube and higher powers of x may be neglected, then 1 plus x raised to the power 3 by 2 minus 1 plus x by 2 whole cube, whole thing divided by 1 minus x to the power half may be approximated as 1 minus 3/8 of x square. Second option, 3x plus 3/8 of x square. Third option, minus 3/8 of x square. Fourth option, x by 2 minus 3/8 of x square. Now let's have a look at these expansions one after the other. 1 plus x raised to the power 3 by 2
What is the expansion of 1 plus x power n? 1 plus nx, that is 3 by 2 into x, plus n into n minus 1 by 2 factorial, that is 3 by 2 into 3 by 2 minus 1 by 2 factorial into x square. We need to neglect the higher order terms, higher power terms, neglect x cube terms onwards. And what about this? 1 plus x by 2 cube, the next term in the numerator. That comes out to be 1 plus 3c1 into x by 2, that is 3x by 2. Again 3c2, that is 3 into x by 2 square. And we neglect this term. X by 2 cube term has to be neglected. Neglect this higher degree terms. So what is this now? After simplification, this comes out to be 1 plus 3x by 2. 3 by 2 into 3 by 2 minus 1. What is that equal to? 3 by 2 into half. That makes it 3 by 4. 3 by 4 by 2 factorial. That is 3 by 8. So 3 by 8 into x square. When you subtract from the other, what is 1 plus x power 3 by 2 minus of 1 minus x by 2 whole cube. 1 plus x by 2 whole cube. What is that equal to? 3/8 of x square minus 3/4 of x square. That makes it minus 3 by 8 x square. Minus 3 by 8 x square. The term in the denominator, that is 1 minus x to the power half, let us raise it to the numerator and we'll write it in the form of 1 minus x to the power minus half. Bring the denominator into the numerator. So that is by making the power of that expression to negative sign. So 1 minus x to the power minus half. Again, what is that? 1 plus minus half into minus x. Again, 1 plus nx. Instead of x, you have minus x. Plus minus half into minus half minus 1 by 2 factorial into minus x whole square. Rest of the terms have to be neglected. Neglect these terms. What is this coming out to be? This is coming out to be 1 plus x by 2. And what is this coming out to be? Minus half into minus 3 by 2. That makes it minus 3 by 4. Minus 3 by 4 into minus 3 by 2. That makes it plus 3 by 4. 3 by 4 plus by 2, that is 3 by 8. So 3/8 of x square there. 3/8 of x square. And rest of the terms, of course, we need to neglect. Okay, now this has to be, these two have to be multiplied. If you multiply, now minus 3 by 8 x square, if you multiply with any other term other than these two, other than this one, if you multiply with x by 2, you get an x cube term. So that has to be neglected. When you multiply with the x square term, you get x power 4. That also needs to be neglected. So in the product of these two, that is, I have brought the denominator into the numerator, and then by making the power of the exponent, the exponent has been made a negative sign, given the negative sign. So finally the answer is minus 3 by 8 into x square into 1 plus x by 2 plus 3/8 of x square. This is what you have to look at. And I need to neglect the terms of degree greater than or equal to 3. So therefore only one term is possible, minus 3/8 of x square. Because if I multiply with x by 2, I get an x cube term. That has to be neglected. When I multiply with x square, again I get x power 4, which is also to be neglected. So the final answer is minus 3/8 of x square, and that falls in the option 3 there. Okay, so option 3 is the right answer. So let's move to the next question for natural numbers m and n. If 1 minus y raised to the power m into 1 plus y raised to the power n is equal to 1 plus a1y plus a2y square, so on, and a1 is equal to a2 is equal to 10, then what is the ordered pair m comma n? That is 20 comma 45. Second option 35 comma 20. Third option 45 comma 35. Fourth option 35 comma 45. Let's have a look at this. 1 minus y raised to the power m into 1 plus y raised to the power n. Now this is a mth degree polynomial and this is a nth degree polynomial. When you multiply them, you will get a m plus nth degree polynomial. So what is that? Now that has been written in this ascending powers of y, 1 plus a1y plus a2y square plus so on. Finally, it will be a m plus nth degree polynomial. So that I will be getting up to am plus n. Okay. But we are interested in finding out the values of m and n. So we need to frame two equations in m and n. So to get that, we have to make use of the fact that a1 is equal to 10 and a2 is also equal to 10. What is a1? a1 is nothing but the coefficient of y here. So how do I get the coefficient of y? If I take a constant term, multiply with a y term here, I get a y. I take a y power 1 term here and a y power 0 term here, I get a y. So what is it? The coefficient of y in the expansion is equal to, in this, let me take y power 0 term. What is the y power 0 term? MC naught. Okay. Into, but I am interested only in the coefficient, so forget about this, MC naught. And what is the coefficient of y in this? I need a NC1 into y. Okay, that's NC1 into y. So again, I need only the coefficient, so forget about this. So what we want is coefficient of y is MC0 into NC1 when I take y power 0 term here and y power 1 term here. Then I can do the reverse. I need to do the reverse also. MC1, but that comes with a minus sign here because you are MC1 into y minus y you will get, and here NC0, y power 0 term. So what is it? Finally, it is MC0 is anyway 1, NC1 is n, and what do you have here? NC0 is 1 minus MC1, that makes it n minus m. What is n minus m equal to? 10. So a1 is 10. Using the fact a1 is 10, we can say that n minus m is equal to 10 there. Now what about a2? How do I catch hold of the coefficient of y square here? So what are all the possibilities? From the first expansion, 1 minus y power m, what are all the combinations we have to look for? 1 plus y power n. I look for y power 0 term here, then a y power 2 term from here, or y power 1 term from here, y power 1 term from here, or y power 2 term from here and a y power 0 term from here. What is the coefficient of y power 0 here? That is MC0. What's the coefficient of y square here? NC2. So what will be in the product, what will be the coefficient? The coefficient will be MC0 is 1, NC2. Coming to this term, y power 1 comes with a coefficient minus MC1. Okay, and here what is the y power 1 coefficient? NC1. What is MC1? MC1 is m. So this comes out to be minus mn. Coming to this, what is the coefficient of y square here? Y square coefficient will be MC2. And what is the coefficient of y power 0 here? NC0. So what we have here is MC0 into minus y square, that is anyway plus y square. So that what will be the coefficient here? The coefficient is MC2. So what we have here is sum of all this. This is one possibility when you group all the y square terms. This is one way we can get y square. This is another way we can get y square. This is another way, the third way we can get y square. So when you group all the y square terms, this will be the final coefficient.
So nc2 plus mn plus mc2 will be the coefficient of y square. Okay. So the coefficient of y square will be nc2 plus mn plus mc2. That is, how much is that? Coefficient of y square is given to be what? 10. Okay. So we have two equations in two unknowns here. What is it? N minus m is equal to 10. And we have here nc2 plus mn plus mc2 is also mc2 is equal to 10. This is equal to 10. Now we can use the fact that n is equal to 10 plus m and write this as an equation only in terms of m. So what is it? N can be written as 10 plus m from here. Okay. So what do we have here? What is nc2? N into n minus 1 by 2. So 10 plus m into 10 plus m minus 1, that is 9 plus m by 2. That is nc2. Okay. M into, what about n? N is 10 plus m. So 10 plus m plus mc2. What is that? M into m minus 1 by 2. That is equal to 10. Now this gives us a quadratic in m, and when you solve for it, you get the value of m to be 35. From here, this is a quadratic in m. You can verify that m equal to 35 will satisfy this. Now when m is 35, what is the n value? Clearly 45. 10 plus 35. Now this is a quadratic equation in m. You can actually plug in the options also and see. Instead of solving the entire thing, we can even plug in the options here. So what are the values of m which can satisfy this equation? So clearly m is equal to 35 will satisfy it. But if m is 35, what is the value of n? We know n is 10 plus m, that is therefore n has to be 45. So the answer is m comma n is therefore 35 comma 45. So the right option is answer 4. Okay, let's move on to the next question. Question number 9. The remainder left out when 8 power 2n minus 62 power 2n plus 1 is divided by 9 is, first option 0, second option 2, third option 7, fourth option 8. Now in this problem we have to look for how to express this terms 8 power 2n and 62 power 2n plus 1 close to some multiple of 9. Now you observe that 8 power 2n, we can write it in the form of 8 square whole power n. What is that? 64 power n. What is 64 power n? We can write it as 63 plus 1 raised to the power n. Okay. Now what about the next term? We have here 62 raised to the power 2n plus 1. That comes out to be, what multiple of 9 is close to 62? 63. So 63 minus 1 raised to the power 2n plus 1. Now let's make an observation here. When you expand this binomially, nc0 into 63 power n, all but the last term will have 63 as a factor. So all but the last term will have 63 as a factor. 63 comes in all the terms except the last. So we can write this as 63 into some multiple integer plus 1. Okay. What is that term? Ncn into 1 power n. What is the term previous to that? Ncn minus 1 into 63. Okay. So we will have all the terms except the last one will be carrying a multiple of 63. So 63 into some integer, this q, we'll call it as some integer plus 1. Right. Coming to this also, again all the numbers except the last is going to have a 63. So we'll have 63, again 63 into some q dash
plus
what is the last term here? 2n plus 1, C 2n plus 1 into minus 1 raised to the power 2n plus 1.
So what is that going to be? Minus 1 raised to the power 2n plus 1 will be the last term.
So it is multiple of 63
plus minus 1 raised to the power 2n plus 1. What is that minus 1 raised to the power 2n plus 1? This is 63q dash minus 1. We can write. Now when you subtract one from the other, 8 power 2n minus 62 raised to the power 2n plus 1. What is it we observe?
We will get a multiple of 63
q, 63q plus 1, 63q plus 1 minus 63 into q dash minus 1. What is that? It's clear that you can club these two multiples of 63 here. So we will get 63 into again some q minus q dash. We'll call it as q double dash or what something. Some number, some integer there. 1 minus of minus 1, what is it? 2 there. Now this 63 we can even write it as 9 into 7. So 9, it's a multiple of 9 now. 9 into 7 q double dash plus 2. So now what is this?
When you divide this number by 9, this will be the quotient and this will be the remainder. So the remainder is
when a number is divided by when the number is divided by 9 is 2.
Why? When it is in the form of multiple of 9. Don't you see it's a multiple of 9 here? Plus 2. So when it is in the form of 9q plus 2, then the remainder is 2 there. Therefore,
the remainder is 2. It's 2. Answer is also 2 there. Second option is 2. Answer is 2. Let's move to the next question here. S1 is equal to sigma j ranging from 1 to 10 j into j minus 1 into 10 cj. S2 is sigma j into 10 cj, j ranging from 1 to 10. S3 is sigma j ranging from 1 to 10 j square into 10 cj. Statement 1, S3 is 55 into 2 power 9. Statement 2, S1 is 90 into 2 power 8 and S2 is equal to 10 into 2 power 8. First option, statement 1 is true, statement 2 is true and statement 2 is the correct explanation for statement 1. Second option, statement 1 is true and statement 2 is true and statement 2 is not the correct explanation for statement 1. Third option, statement 1 is true and statement 2 is false. Fourth option, statement 1 is false and statement 2 is true there. What is S1? Sigma j ranging from 1 to 10 j into j minus 1 into 10 cj. Okay. Now before we proceed to do this problem, we'll have a look at this identity. R into NCR is equal to n into n minus 1 C R minus 1. That is, when you supply R to NCR, this n pops out, the first factor in this numerator pops out, and then you will be having n minus 1 CR minus 1. Suffix, superfix and suffix are both diminished by 1. So R into NCR is this form. Okay, now further, if you multiply by what is R into R minus 1 into NCR. So that's going to be, this R into NCR is nothing but n into n minus 1 CR minus 1. So we'll get R minus 1 into n minus 1 CR minus 1. Let's write out this R, n out. So what do we have? N into R minus 1 times of n minus 1 CR minus 1. So now this R minus 1, when you have these two matching here, we have n popping out and then
this n is superfix and suffix are both diminished by 1. That's how you can remember it. It's a simple thing to derive, but let's remember it that way. So when you supply this r minus 1 to this n minus 1 cr minus 1, these two are matching here. Therefore, what is it? This n minus 1 factor will be popped out. Okay, so we'll have n into n minus 1 into, now what do we have here? This n minus 1 cr minus 1 superfix and suffix will both be diminished by 1. So we'll have n minus 2 cr minus 2. So this is what we have. So making use of this fact here. So what is it now? Instead of r, j, r you have j that there. In fact, the summation would start from 2 to 10, because when j is equal to 1, anyway it will be 0. So S1 is actually, can I write this as, what's the general term here? J into j minus 1 10 Cj, when you supply it, what pops out? 10 into 9 into n into n minus 1, n is 10 for us, 10 into 9 into 10 minus 2 C j minus 2. J, okay, sigma j ranging from what to what? Actually it will be 2 to 10. To 10 there. So that comes out to be, let's see what this turns out to be. Here we have, okay, 10 into 9, that is 90, into 10 minus 2 C j minus 2. What is that? That comes out to be 8 C j minus 2. 8 C j minus 2, j ranging from what to what? 2 to 8. What is this coming out to be? 90 into, what is when, what is the term when I put j equal to 2? 8C naught, 8C, next I will be getting 8C1, so on so forth, 8C8. J is equal to 2 to 10 there, so the last term will give me 8C8. So that will be 90 into sum of the binomial coefficient in the expansion of 1 plus x to the power 8. What is that going to be? 2 power 8. So 90 into 2 power 8. So the S1 is 90 into 2 power 8 here. That's something that we have arrived. S1 is 90 into 2 power 8. So let's keep that aside. Now let us look at S2. What is S2? Sigma j into 10 Cj. Now observe that it is like this, it is in this form. J ranging from what to what? 1 to 10. So what is that? R into NCR type, where R is, in place of R we have J, and we have in place of N 10. So what do we have this to be? Sigma j ranging from 1 to 10. 10 pops out, so 10 into, now this has to be diminished by 10 minus 1, that is 9C j minus 1. 9C j minus 1. Okay, so that is going to be 10 into sigma 9C j minus 1, j ranging from 1 to 10 there, 1 to 10. So what is that? 10 into 9C naught plus 9C1 plus so on 9C9. What is 9C naught plus 9C1 plus so on 9C9? That's nothing but 2 power 9. So 10 into 2 power 9 there. Okay. So this is what we have here. Clearly, so what is it? Statement 2 is false. Because we are saying that S1 in the statement 2 it's said that S1 is 90 into 2 power 8, S2 is 10 into 2 power 8. So that rules out the first option, second option are ruled out. Now the third option is the only option that we have here. First statement tells us about S3. Now let us look at S3. What is S3? What is S3 here? Let's look at S3. What is S3? Sigma j square 10 Cj. 10 Cj, j ranging from 1 to 10.
we can write this as j into j minus 1 plus j into 10cj. So what is it? You please observe that it is j into j minus 1, that is j square minus j plus j. That makes it, I have just introduced a j with a plus sign and a minus sign here, and then j ranging from 1 to 10 here. So what do you observe? This j into j minus 1 into 10cj, that is nothing but your S1. So it is coming out to be S1 plus. What is sigma j into 10cj? We can split this summation into two summations, and that turns out to be, that was what? S2 here. Okay, what is that? 90 into 2 power 8 was S1 plus 10 into 2 power 9 is what you have here. Okay, so clearly we have here, we can take out 2 power 8 common into 90 plus 20. So that makes it 110. 110 into 2 power 8. That of course we can write it as 55 into 2 power 9. 55 into 2 power 9. So clearly the option is, statement 1 is correct. So S1, we are saying that in the statement 1, S3 is equal to 55 into 2 power 9. Please make an observation here. This j square was written as j into j minus 1 plus j. Now I split this summation into two summations. What is that? Sigma j into j minus 1 into 10cj plus sigma jcj, j into 10cj, j ranging from 1 to 10. So this has been split into two summations. This part is S1 and this part is S2. So S3 was simply S1 plus S2, and after simplification we find that it is 55 into 2 power 9, which is clearly, which states that the statement 1 is correct, whereas you observe that statement 2 is false, because what did you get S2 to be? 10 into 2 power 9, but the statement 2 says that S2 has to be 10 into 2 power 8. So the answer is option 3 is the right answer.